Welcome again. Today we will learn about monosaccharides. Last day we have learned about the different types of carbohydrates and its definition, but today we'll mainly focus on the different types of monosaccharides. Welcome to Educators, myself Manjishta Chatterjee. Don't forget to like, share and subscribe and put the bell icon for more notifications on the updates. Now the question lies, what are monosaccharides? From here, you can understand if you consider the word mono means one, and saccharides comes from the word sugar unit. So when a compound contains only one sugar unit, they are considered to be monosaccharide. Mono means one and saccharide means sugar unit. The general formula of monosaccharide is CnH2ON. Now, what are these basically? These are compounds which are simplest in nature. As you can understand, mono, that means only one sugar is there. One sugar unit is there. And when it is one, it is the simplest form. So any complex carbohydrate, whatever we are taking, that are broken down into these monosaccharides, which are the simplest carbohydrate containing free aldehyde or ketone group. Now, if we classify monosaccharides, we have different kinds of sugars. Like depending on the number of carbon they have. There can be 3 carbon monosaccharides, 4 carbon monosaccharides, 5, 6 and 7 respectively. And each of the variety has an aldehyde group and ketone group. Suppose the monosaccharides containing 3 carbon are named as trioses. So if aldose, that means considering or containing one aldehyde group, these are known as glyceraldehyde. Whereas if they consider to be in the ketone group, then triose will be dihydroxyacetone. Similarly, tetroses, pentoses containing 5 carbon. Over here aldose groups or compound containing aldehydes are ribose and xylose, whereas ketoses are ribulose and xylulose. The main thing which we will learn in detail, the most common ones are the hexoses. That means these monosaccharides, they contain 6 carbons and are known as hexoses. The compound which monosaccharides containing aldehyde groups are mainly glucose and galactose, and those containing ketone group is only fructose. Just go through the names of the rest. Like if I ask you, name one pentose sugar, then you have to write, you can cite the example as ribose or xylose or xylulose, etc. Or maybe a heptose sugar, so you can write glucoheptose, pseudoheptulose, like this. So monosaccharides are classified on the basis of the carbon they have into trioses containing 3 carbons, tetroses 4, pentoses 5, hexoses 6 and heptoses 7, and they have an aldehyde variety and also a ketone variety. Mainly we will deal with the hexoses, under which the aldehyde group containing monosaccharides are glucose and galactose, and ketone group containing monosaccharide is fructose. So the first hexose that we will learn is glucose. It is also known as dextrose, corn sugar or grape sugar. The other names are very important. And basically all complex carbohydrate lead up to glucose as the end product. So any digestion of complex carbohydrate lead up to glucose as the end products, and glucose are those compounds which are very easily absorbed by your blood, and they can directly as they are the monosaccharides, they can directly move into your bloodstream. Basically, this is the structure, this is the straight chain structure of glucose, and this is the alpha D glucose or the ring structure alpha mode, and this is the ring structure beta mode. Basically, these are the mirror image we can see. Okay, so there is a compound, there is a process in glucose formation which is known as mutar rotation, and on the basis of this mutar rotation, this mirror image of glucose, that is alpha D glucose and beta D glucose, are formed. Now we know that glucose is a 6 carbon atom, it's a hexose compound. So let us count, and the formula is CnH2ON. That is, let us count this carbon first: 1, 2, 3, 4, 5, 6. So in straight chain there are 6 carbons total, and there are 1, 2, 3, 4, 5, 6 oxygen, and double will be the hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the formula becomes C6H12O6 for glucose. And we over here we have this aldehyde groups bond CHO. So glucose is a compound containing 6 carbon atoms, and basically they have have an aldehyde group. Now as you can see over here in this picture, what we are showing, the straight chain structure are transferred into a ring structure just by connecting the last end to the first end. By this we are getting the same structure in a ring posture or a ring position. Over here also, if you calculate, there are 6 carbons: 1, 2, 3, 4, 5, and 6. The oxygen will be also 6: 1, 2, 3, 4, 5, 6, and the hydrogen is just the double. Over here it is also same, as you can see, only this position, that is the first carbon position, is different. Over here you can see the H is on the top, and in this case in beta D glucose the OH is on the top, just the mirrored image of the same. You can write any one. Basically we mainly write the alpha D glucose format when we are writing the, we follow this when we are writing the glucose ring structure. So whenever I'll ask you to write, or you can write the straight chain structure, so this will be the straight chain structure and this will be the ring structure. Next we move on to the sources of glucose are mainly grapes, berries, uh, sweet fruits, oranges, and also some sweet vegetables. Another sugar which is very important as monosaccharide, also known as fruit sugar, is the fructose. It is basically a different group. They are not the aldehyde group. In glucose we have seen the bond CH, over here it is not there. So again two, due to mutual rotation, again two structures has been shown. So you can just take this, basically we take this D fructose structure over here. So CH2OH, in the second carbon we have the C double bond O, that is the ketone group. Third carbon always OH on the left side in D fructose or D isomerism, and HCOH, HCOH is the same formula C6H12O6 but with a different functional group of C double bond O. And over here again the same chain has been roundabout made into this kind of, you know, ring structures. So this is also the same, you just can write it over here. So this is a structure as well. So write the fructose structure, practice it, and it's very important. If we go to the um, different sources of fructose are mainly honey and ripe fruits, few vegetables. Third, which is again known as a sister of glucose, is galactose. And galactose also, like glucose, have aldehyde group. It is not found free in nature, and it's mainly found from lactose, which is a disaccharide, which we will be learning in the next video. So in the monosaccharide, galactose is basically containing again C6H12O6. All the formula is same, and they contain the aldehyde group like this. The only difference from glucose is that glucose, only the third carbon, that is this carbon, is containing OH or the hydroxyl group on the left hand side, whereas in galactose both the third and the fourth carbon is containing the galactose on the left hand side. So if you can just take the chain again and make a roundabout, you will get this structure of galactose. Please do practice this. This is very important. You can see this is OH is just third and fourth carbon containing both OH on the opposite side. And as I said, lactose is the only source of galactose. Lactose is mainly found in all the milk and milk products. So galactose's source is also the sources that we get from which we get the lactose. Next, few properties of carbohydrates which are very important. You just need to know the name and the one line definitions that I've just given you like this. What is isomer? When any two compound having the same molecular formula but different functional group, they are known as isomer of one another. Here glucose and fructose have both of them have the functional group, but they have different functional group. Like glucose have an aldehyde as the functional group, and fructose have ketone as the functional group, but both of them have the same molecular formula of C6H12O6. So glucose and fructose are the example of isomer. Isomer means compounds or monosaccharides or saccharides or any compound containing same molecular formula but different functional group. Glucose and fructose both have the same molecular formula of C6H12O6, but the functional group of glucose is aldehyde while that of fructose is ketone. Next, another property is very important, which is known as epimar. That was isomer, this is epimar. Epimar is basically same molecular formula but the different orientation of the hydroxyl group, or the position of the hydroxyl group is different. Like in that case of glucose and galactose, both of them are sister. They have the both same functional group, same formula of C6H12O6, but in glucose only the third carbon has an OH on the left hand side, or the hydroxyl group on the left hand side, whereas in galactose we can see both the third and the fourth carbon have hydroxyl group on the left hand side. So they are the epimar of one another. So please write this down, the epimar, what is isomer, and please mention the examples. This is very important. Another very important property of carbohydrate is being a reducing sugar. Monosaccharides are all reducing sugar. These are the tests that we do to identify sugar. In class 12 there are different tests to identify monosaccharides, and we do by this theory or this property of reduction. So monosaccharides, they have free aldehyde and ketone group which itself oxidize and can reduce compounds like Benedict's solution, Fehling solution, or Tollens reagent, and can change their look, and that is known as the reducing sugar or the reducing sugar property of monosaccharides. Why? Because they only have free aldehyde or free ketone group which basically can reduce the compounds. So if a Benedict's test is to be done, what if there is no sugar, or the normal Benedict tests solutions color is blue colored, when there are traces of reducing sugar they will show a green or a yellow PPT. PPT means uh, precipitation over here. And if there is a moderate amount of sugar, that means it is orange, and large amount of reducing sugar will give you a brick red precipitation. So if you have a monosaccharide and if you are allowing any of this Benedict's, Fellings or Tollens solution, they will reduce the compound and change the color into something else, like in Benedict's it is changed to brick red precipitation. So I hope you have understood the different monosaccharides, the functions and the properties of them. Please go through it again nicely. That's all for today. Thank you so much.